I welcome you all to today's lesson where we are going to talk about convex lenses. I'm here to make this topic very simple so that you can easily understand it. So before I proceed, what I want you people to know and understand is that convex lenses, these are thicker at the center than at the edges. This is what I've just illustrated. The center, these are thicker at the center than at the edges. Here at the center, these are thicker. Have you seen? Than at the what? At the edges. This is the reason why it is called a convex lens. And the other name that we can use apart from a convex lens is that these are called converging lenses. And the reason why they are called converging lenses is because they cause a parallel rays of light to converge at the focal point after passing through the lens. So the focal point that we are talking about, it is here. This one here, it is called a focal point. The other name that we can use, we can call it a principal focus. This is what you need to know and understand. And one thing you need to know is that convex lenses, these are very important and they are used in so many applications like image formation. When we want to talk about magnification, we use a convex lens. So even as we study this, I want you people to know this and understand. So I've drawn this diagram so that we can try to understand certain terms that I'll be using. The first thing that I'm going to start with is this point called optical point or optical center. This one is called optical center. So the C there, this C there, so I'll do this so that you understand. The C there is called the optical center. So we get to call that as the optical center. So if I ask you, where is the optical center? So this is the what? This is the center of the lenses. So the center of the lenses is called the optical center. They see there. So the center of the lenses is called the optical center. Make sure you understand this. And the other thing that you need to understand, we've got this axis. This one is an axis. The same way we have x-axis, y-axis. So we've got this axis. The name of this axis is called the principal axis. So this one is called principal axis. We get to call it as principal axis. It is called a principal axis. This is the line passing through C and it is perpendicular to the what? It is perpendicular to the plane of the lens. So the plane of the lens, have you seen? These are the plane of the lens. They are perpendicular. So the line or the axis which is perpendicular to the plane of the lenses is called principal axis. This is what you need to know and understand. Make sure you get these points very well because even as we get to move on, you are going to be meeting some of these terms. So I want you to understand when I say a principal axis, you already know that this is a line that is passing through optical center and it is perpendicular. When I say perpendicular, we understand that it is making a 90 degrees somewhere there. Have you seen? It is perpendicular to the plane of the lenses. This is what you need to know and understand. This is. Then we also have a principal focus. This point F there, the point F, these points F, that point F. So F is called principal focus. It is called a principal focus. The other name that we can call it, I told you at first, we can say this is the focal point. It is called the what? Focal point. This is the other name. So make sure you understand these terms that I'm using. You can call it a principal focus or you can call it a focal point. So this is a point where rays are parallel to the principal axis. Have you seen this one? It is here. This is a point. So this is the point where ray parallel to the principal axis converge. So they get to converge at this point. This is where they get to converge. So the point where ray parallel to the principal axis converge here at this point. This is where we get to call this as the focal point, or the what? Principal focus. Have you seen? So these are along the what? Along the principal axis. Principal axis along. So this one is along the principal axis. The optical center. This is where the center of the lens is. And the focal point. This is a point that is along the what? Along the principal axis. So I want you people to understand all these terms that I'm saying. And the distance from the optical center, this distance from the optical center to the focal point, this is called focal point, or you can call it principal focus. So these are the terms that I'll be using interchangeably, so don't be confused. So the distance from the optical center to the focal point, this distance which is here, it is called the focal length. So we get to call this as focal length. This f, the distance f there, small f. So small f there, I will say that small f there, it is called the focal length. This is what you need to understand. It is called the focal length. So these are some of the things that you people need to know and understand. So the distance from the optical center to the principal focus, or to the focal point, is called the focal length. So we get to call it as the focal length. This is what you need to know and understand. So make sure you get everything here that I'm saying. These are things that you are going to encounter even in your exams. So let us now look at the rules that you need to know in order to draw the ray through a lens. So let us look at the 3 rules that are supposed to be known each time you want to draw the ray through the lens. So let us look at that. So the first rule that you need to understand to draw the ray diagram through lenses is that rays parallel to the principal axis are refracted through F, that is focal point. So let's say you've got a ray. This is, we've got a lens like this. So I'm just here to make you understand what I'm saying. Then you've got something like this. Have you seen? So you know that this is where I've got the focal point, even there, the focal point. Then here we've got what we call optical center. So I won't do that. So a ray that is parallel. So it is parallel like this. Have you seen? Here, it is parallel. So it is coming like this. It is parallel. So this ray is parallel straight like this. It is parallel to the what? Principal axis. So these ones are refracted through F. They are refracted, so it is going to converge like that. It is going to go down like that. So it is the first principle that you need to understand. So parallel rays to the principal axis are refracted through F. So this is the part that you need to understand. Make sure you understand this one. We only have 3 of them. So this is the first one. When it is parallel, this one is parallel to the what? This one is called the principal axis. So when it is parallel to the principal axis, when it meets this lens, we know that these are convex lenses. They are going to converge. So they are going to change. This one, like this, it will be refracted, the bending of light. So it is going to be refracted through F, which is the focal point, like that. This is what you need to understand. This is the first law that you need to understand. Let us move to the second law. Let us move to the second law. So the second law that you need to know, so I'll do this. The second law that we need to understand is that rays passing through, so the rays that are passing through, F are refracted, so these are refracted parallel, they are refracted parallel to the principal axis, This is the second one that you need to understand. So meaning that if this is, let me draw a lens like this. So principal axis, this is plane of ray like this. Then you know this is the focal point. Even there, this is the focal point like this. So passing through F, so it is passing through F like this, passing through F like this, passing through F, it is passing through F like this. So rays passing through F, it is passing through F like that, are refracted parallel to the what? Principal axis. They are refracted parallel. So parallel like this, it will go straight like this. It is parallel. So this one is parallel to this one here. The principal axis, this one is the principal axis. This is the second one that you need to know. So as long as it is coming down here, passing through F, the moment it reaches this plane of lenses, it is going to be refracted parallel to the principal axis like this. So all these things that I'm telling you, you need to know them. So you need to understand them very well. Make sure that you understand them clearly, because if you won't understand them, it will be very difficult for you to answer an exam question without knowing, especially these laws. It is gonna be very difficult for you to answer a question. Let us look at now the third one. Let us look at the third one, which happens to be the last one. We look at the last law. So these three ones, you need to make sure that you know them and understand them. So we look at the last one. So the last one is like this: rays passing through optical center, which is C. So rays passing through, so the rays that are passing through, passing through C, we know that is the optical center. Continue, so they continue in a straight line. Continue in a straight line. This is what you need to understand. They continue in a straight line like this. They get to continue in a straight line. So for example, principal axis, plane of rays like this. So here, this is where I've got the C. So that passes through here. It is coming like that. Have you seen? So it is going to continue in a straight line like this. It is going to continue in a straight line. So these are the three rules that you need to understand before you talk about a ray diagram. This is what you need to know and understand. So let's make sure that we understand these 3 points that I've just shared with you on how to draw the ray diagram through lenses. So now, the other thing that you need to know is how to locate the image through a lens. How can you locate an image through a lens? How can you locate an image? So this is the tricky part now. Make sure that you understand this part very well. So I want you people to understand this part very well. So you want to locate, how to locate an image, how to locate an image, how to locate an image. So how can you locate an image? So how to locate an image through a lens. So it is through a lens. How can you locate an image through a lens? The first one that you need to know is that you need to use any two rules, those ones that we've just from discussing, any two rules. So you need to know two of them, at least two, you need to know them. So you get to use any two rules. So two rules will really help you, especially the first one and the second one, even the last one. Those ones are very simple. You need, maybe this point I'll just say you need to know all the three rules. Then the second one, for you to locate an image, you need to find the intersection part. So you need to find what? You find the intersection part. You find the intersection part. So you need to find the intersection part. You need to find the intersection, I'll say intersection point, where the two rays are meeting or they are intersecting. So this is what you need to know and understand. I want you people to know this, understand this better, so that you are even able to answer exam questions under this. So what you need to understand whenever we are talking about this is that, especially on the intersection part, the first point that you need to know is that if the diffracted ray intersects at any point, so if they get to intersect at any point, when they intersect at any point, it means that the image is real. So if they intersect at any point, it means that the image is real. The other point is that if the refracted rays do not meet or do not intersect, it means that the image is infinity. This is what you need to understand. The last point that you need to know, so talked about the first point. The first point, I said that if they intersect, so if they intersect, it means that the image is real. Have you seen real image? Then the other point I said, if they do not intersect, it means that the image is infinity. Image. So it means that image is infinity. This is what you need to understand. And the other point is that if the diffracted rays extend behind the object and the extended lines intersect at any point, the image is. So this, the last point that is that the image is virtual. This is what you need to know and understand. So you get to understand these 3 points that I've just shared with you. Make sure you understand them. So these are points of doing this. So the first one, you know it. Second one, you need to know it. And the last one, you need to understand it. So make sure that you understand these very well. Make sure you understand them very well. So let us look at an example. We look at an example, various diagrams that you need to know. Let us look at an example now. So this is the first one that I want us to discuss about. So here, the object is between the focal point and the optical center. Optical center, you know that this is, then the point is, that is the focal point. So this is the object, or here. Have you seen where it is? There. This is where the object is. So you know that this one came straight. When it is coming straight like this, when it just coming straight, it passes through the optical center, it continues in a straight line. But this one passing through F, it bends, or it is refracted parallel to the principal axis. This is what I told you. So when it is coming like that, it bends like this, parallel. So in an exam, they'll just put a line there. Then you know that when it is coming, when it passes through the focal point, then it is refracted parallel to the principal axis like this. So in this case, the image is between F and C. So now, how can we know the properties of this? The object is between F and C. So when I continue extending this, when this is extended like this, have you seen? And this one I extend it like this. When I extend it like this. Have you seen where they are meeting? They are meeting where? At that point. That is where they are meeting. So since they are meeting at that point, meaning that here, this is where we've got the what? The image. This is where the image is. So if this is F, this one here will be 2F. Have you seen? This one here will be 2F. And here I can put a point there to say I've got 2F, this other point like that. So have you seen? Here, if you extend this, the point that I told you at the last point which I said that if the refracted rays extend behind the object and the extended lines intersect at any point, the image is virtual. This is what I said. It is what? Virtual or virtual. So now, in this case, have you seen where they have met? So meaning that we can say the image is what? Image is virtual. And the other point that we can note is that the image is formed between what? 2F and F. Image, this is what you are able to see. Image. So these are things you are able to see. Image is between, so the image is between what? 2F and F. This is what you are able to see. And the other one is that the image is magnified. The image is magnified. So how can you know that the image is magnified? You know that magnification is where the image is larger than the what? The object. So this is the object. Have you seen? We've got a small object like that. It has been magnified like that. And it has been magnified upright on the same side. So I'm going to say the image is magnified. So make sure you write down all these properties that I'm saying. The image has been what? The image has been magnified. You know what magnification is. And the other thing that you need to know is that the image is upright. The image is upright. This is what you need to know and understand. So I'll say the image is upright. So I've given this point. I've also given this point. I've given the third point. And the fourth point that I'll give you is that the image is upright. So the image is what? Upright. This is what you need to know and understand. So when an object is placed beyond the focal point of a convex lens, a real inverted image is formed on the opposite side. So when it is formed on the opposite side, we say that the image is inverted. On the other hand, when an object is placed between the lenses, so when the object is placed between the lenses and the focal point. So the lens is here and the focal point. Have you seen we've got the object there which is placed between the focal point and the lens. So between the focal point and the lens, a virtual upright image is formed. So there is upright, there is a word here I said at first which is virtual. So a virtual upright image is formed. Upright, I said the image is upright. So this is what you need. And these are formed on the same side as the object. So they are formed on the same side as the object. So on this point, what you need to know is that when an object is placed between the lenses and the focal point, this is the focal point, a virtual upright image is formed on the same side as the object. So an upright virtual image is formed on the same side as the what? Object. This image is formed on the same side and the object is between the lenses and the focal point. So meaning we are going to have an image that is upright and virtual. This is what you need to know and understand. So hope, and on the magnification part, you know that when the image is larger than the object, it means the image is magnified. The image is what? Magnified. We only have magnification and diminished. So you need to know if the image is diminished. When the image is diminished, it means that the image is smaller than the object. But if the image is bigger than the object, it means that it has been magnified like that. This is what you need to understand. And the other point is that when the image is formed on the opposite side, it means that the image is inverted and the image is low. This is what you need to know and understand. So make sure you understand this. So this is the first part that we've talked about. Let us also look at another part. We look at another important part. This is the second one that you need to know. So where the object is at F, the object is at F. So when the object is at F, what we observe is that when we try to extend these lines, even if we extend them, they can't meet. Even down here, these, they can't meet. So what you understand is that I talked about a point where I said that if the points don't meet, if there is no intersection, meaning that the image is infinity. So if you check here, this object that is at F, meaning that the image is what? Infinity. The image is infinity. This is what you need to understand. The image is what? Infinity. So you need to understand all these things that I'm illustrating here. Make sure that you understand them clearly, you know them, and understand even these properties that I'm giving here, the characteristics. You need to make sure that you understand them and you know them, because you are going to encounter such questions. So where you know that if the object is at F, you even know at focal point, you even know that this is what is going to happen. So in an exam, they will just give you maybe lines that, a line that is from here to there, this line that is from here to there, then they tell you to complete. So you know that when it is passing through F, it is refracted parallel to this axis. This one passing through F, passing through the optical center, it just goes straight like that. So anything that will look like this, it means that the image is infinity. The image is infinity. This is what we need to know and understand. Let us look at now the last part in this lesson. This is the last one that we are going to talk about. So in an exam, when they just tell you that An object is between 2F and F. These are the properties that it must have. So you need to make sure that you understand it. Have you seen the way it is like this? The same way I've written it like this. Meaning that the image is formed beyond 2F. Have you seen? This is the image. This is the image. Have you seen where the image is? The image is there. Then the object is between 2F and F. This is where the object is. This is where we have the object. So these are points that you need to understand. So the characteristics of such a lens, or the characteristics of rays on this lens, is that the image is beyond 2F. Have you seen this image? Image is beyond 2F. So image is beyond 2F. Image is beyond. The image is beyond 2F. The second one that you need to know is that the image is real. The image is real. So the image is real. This is what you need to know and understand. How did I know that the image is real? Earlier on, I said that when an object is placed beyond the focal point of the convex lenses, a real inverted image is formed on the opposite side of the lens. This is what I said. On the opposite side of, have you seen where the object is? Opposite side of the lens, this other side. So beyond, have you seen? Beyond the focal point, meaning that the image here is the inverted real image. So real, so the other point that I will put here, it is not upright, inverted. So image is inverted. This is what you need to understand. So when an object is placed beyond the focal point of a convex lens, a real inverted, so real inverted object is formed on the opposite side of the lens. So these are 2 points. Don't say real inverted. You can just say image is real, image is inverted, just like that. This is what you need to know and understand. So make sure you understand these points very well. And the other one is that if you look at this is the object. Have you seen this one has gone down? Meaning that the image is what? Magnified. The image is also magnified. Image is what? Magnified. The image is magnified. You know what magnification is. So these are points that you need to understand. When it is pressed, so make sure you study this. When it is just pressed between 2F and F, you already know the properties or the characteristics. When the object is between F and C, I gave you the characteristics that you need to know. And if the object is at F, you need to know those characteristics. So I'll give you 3. We are yet to do more on this. So in this lesson, we are just going to end at 3. So make sure that you understand these 3. You get and understand. So make sure you are studying these. You are able to understand these 3 things. Thank you so much. And don't forget to write them in your book.